Hi, Assalamu alaikum. I am Dr. Nadeem, and today we'll start our new session uh, in the same series, Object Oriented Software Engineering. And today, our topic will be the Unified Process Model and Introduction. So we have our first lecture, if you remember, that was regarding the basic concepts of object-oriented programming paradigm, and now we'll move forward to see this topic that is one of the most important topic considering the object-oriented software development is the unified process model. So whenever we talk about the unified process model, keep some things in your mind or just recall the concept of the process model. So we have gone through with the traditional software engineering processes and where we have seen number of models. For example, you have gone through with the waterfall model, or you have also discussed the spiral model, iterative model of development, rat model. So there are a number of process model which you have discussed in a traditional software engineering paradigm. So here we are talking about, or we will talk about, the unified process model, which is more specific towards the object oriented software development. So what is the unified process model, and what are the important phases of that unified process model, how to incorporate those phases into the software whenever we are designing such a software or developing a software. And so we need to understand all these things in this lecture. So what is the unified process? You can say is an iterative modern process model or a framework derived from the work on the UML and associated process. What UML is? That is unified modeling language, as you know, which is basically based on graphical notations, and UML composed of more than 14 models, and all those models depict various different relationships and different models uh, in the design phases, in the analysis phases, as well as in the development phases, which includes use case model. If you remember, it may include the class model, state transition model, sequence model, collaboration model, component model, deployment model, and there are other models as well. So in the next lecture, we'll also talk about UML in detail, but there you need to understand that this is, first of all, whenever we talk about the unified process model, remember it is an iterative model process model derived from the word work on the UML and the associated process, the leading object-oriented methodology for the development of large-scale softwares, and obviously it's a standardized model, and we need to understand that how that model actually works, and number two, how we can relate that model to the earlier model as well. So what is different in that model and how it can be interrelated with the UML concept. So the third point you can see that maps out when and how to use the various UML techniques. So the unified process model, if you take this into perspective, so remember, the most of the world we are dealing with is not object oriented. The principles we see or we observe, or the real world notions we see, or the real world situations we see, but what we do is that we want to represent that information into an object oriented design or representation, um, and for that purpose there is a dire need that we need to have a model where we can represent things in the same manner. That should be a standardized approach, and that can be used in the development process, because earlier on there were different approaches, and all these approaches were being used in the software object oriented software design methodologies. But we are thankful that in 1999 the three giants of you can say the object oriented programming paradigm, the three giants, which is Jacobson and Ramberg, they actually work together, and they have published a complete object oriented analysis and design methodology that unified the separate different methodologies which exist earlier on. And the good thing is they came out with this unified process, which is now a standard model and which can be incorporated, which can be used whenever you are developing applications in object oriented paradigm. So it means now you can say the unified process model is an adaptable methodology, is an acceptable methodology. It is widely used methodology. It has to be modified for the specific software product to be developed, because we are developing projects which are of different nature. So it is very important for us to understand that how we can incorporate various models and what adjustments we can make in those models to have a better understanding of those projects. So therefore it needs some sort of modifications which can be done as well. So that is the basic, you can say, some of the historic aspect. What is the unified process? It develops high risk elements in early iteration, which is very important, because once you develop those high risk elements, it is easier for us to deal with those elements rather than discovering these elements later on, and obviously then you have no time to mitigate those, and therefore it will be difficult for us. So there we develop those high risk element in the early iterations. So we actually find out these cases earlier on. So deliver value to the customer. Of course, it is customer oriented as well, and that also involves the customer interactions in terms of use cases, scenarios which we need to develop, and obviously it is when we talk about a value, of course, it is one thing which goes into the favor of unified process model. Accommodate change early in the project, because changes need to be incorporated, and if there is a certain change, we can accommodate early in the project, because this is an iterative model. So although we have phases as well, but if we observe that there might be a certain change, we can go back and we can modify the object definition, and therefore it can be easily represented in the model. Work as one team, obviously it's a team oriented approach. Adaptable methodology can be modified for the specific software product to be developed, as we have discussed earlier on, which is a good thing. It is not a stringent or sort of a methodology where there are strict divisions. No, there is an overlapping as well. There is a flexibility as well, and you can also modify it. Two-dimensional system development process. It means that here we have the set of phases which we'll discuss later on, and also the workflows. So what we will see that how those phases and workflows will work. For example, if we are in the phase 1, what are the workflows which should be there, which when we are in the phase 2, which workflows actually we will see, and how it will work. So that is why it is you can say it's a two-dimensional approach. The unified process model is basically when we talk about various phases, you will see later on that all those phases actually involves various models which are basically defined in UML. And what UML is, Unified Modeling Language, which is graphical in nature, means there are graphical notions which represents a certain artifact. So UML itself is graphical. UML diagrams enable software engineers to communicate quickly and accurately. Why it is important? Because it's a standard, so it's a standard model. So let's suppose if you have a class diagram, so it is easier for you to, for the developers to engage other developers and try to find out what is actually wrong in the particular design. Is there any improvement which is required? Is there any change which is required? Or that design can be further improved. So it speaks itself. So whenever we communicate with each other, for example, in terms of a use case model or a class model, or even a state transition or a sequence model or any architectural diagram. So unified process model is a modeling technique which consists of various diagrams or models, and which can be incorporated in various phases of a unified process model. The object-oriented paradigm itself is an iterative and incremental in nature. It means that there are phases. So whenever we have phases, it means we are talking about increments. And whenever there are certain activities which need to be repeated, it means they are iterative in nature. So object-oriented paradigm has both the concepts. So it is iterative, it is incremental. So every time we need to rethink about the definition, and that definition has to be improved. So there is no alternative to repeated iteration and incrementation until the UML diagrams are satisfactory. So now we will talk about the various phases which are there in the unified process model, and in that there are 4 phases actually. You can see on this slide. One is inception, then followed by elaboration, then construction, and the last phase is called transition. And all these phases has certain objectives, certain you can say workflows which should be there, and obviously there are certain outputs which have been obviously can be identified in all those phases. So inception basically is the first phase, which establishes the business case for the system. It means it defines the scope of the system. So what are the functional requirements? What are the non-functional requirements? Basically it deals with all those functional requirements which are part of the system. It deals with all those business cases which are relevant. And when we talk about relevance, and it means that we're talking about the scope of the system. So inception itself also established the scope of the system. It also defined risk, all those risks which are there. So whenever we are defining various scenarios, various situations, we also define various risks, in what situations those use cases can be executed, what are the failure scenarios, how those interactions can be captured. So the basic concept in that phase is to determine those requirements in terms of functionalities, and to see and to observe what are the relevant objects which are there. So it is important for us to identify those objects and of course the relevant behaviors which are associated with those objects, and the interactions as well among those objects. So to identify those functionalities, identify earlier business cases, scope, risk is basically the part of the inception phase. And when you talk about UML models, so from UML models you can say the most important model is a use case model, because in use case model we usually determine all those use cases which are actually the functionalities, major functionalities of the system, and those functionalities can be identified in the form of use cases. And obviously the use cases are basically the scenarios or the situations where we have the interactions, and that is one of the core concept of object-oriented unified process model. So that is our inception phase, leading to the elaboration phase, where we need to develop an understanding of the problem domain and system architecture, of course, because it is more design oriented. So whatever the requirements we have to convert them into an analysis model, leading to a design approach. We need to develop the design model. We need to see that what relationships those objects might have, whether there is something which can be represented better in terms of aggregation or better representing composition, association, or maybe the inheritance, how those methods should be defined, where those methods should be defined, which responsibilities to be assigned to which objects. So all these things become relevant when we talk about elaboration. So for example, a class model itself, a detailed class model itself is a very good design model for the elaboration phase. Then it leads to the construction, where we go for the detailed system design and leading towards development, and of course the testing. So construction means that we are going to the physical designs, final designs, detailed designs. We are going to construct means develop those artifacts which we have defined earlier on, and to see how it will work. So what I have incepted, how I have elaborated, and now I want to see how it will work, and also not only work but to see that whether it works correctly or not. It means we have to invoke some of the testing methods as well. So, and to try to build that system in short iterations, leading to another phase which is called the last phase, which is actually the last phase, that is called transition. So deploy the system in its operating environment, because remember, whenever we are developing any application or a software, keeping in mind the realistic scenarios, everything, we have modeled everything, but remember that system or an application has to work in a real world scenario, and a real world scenario is always a different scenario from a creating environment. So transition involves the most important part, that is called the deployment of the system in the operating environment, the real environment. You need different releases as well. You have to manage various releases, the updates, the feedbacks, deployment strategies, how you deploy your system, what strategy you will observe and you will follow. So these are the four important phases: inception, elaboration, construction, and transition. We have talked about the unified inception phase. What are the objectives, gain, and understanding of the domain? That is, the domain part is very much important in the inception phase. For example, if we are developing application for a health oriented system, so obviously we people are not very much aware of health related systems, so we need to have that domain information. You should invoke those methods where you can get that domain oriented information from domain experts, from various documents, existing systems, and try to understand and represent that system based on the given requirements. Obviously the objective is to delimit the scope of the proposed project, define the initial business case for the proposed system, including costs, it is important, schedules, how it will work, which activities to be followed, the timeline, what are the risks which are associated with that development process, priorities, development plan, define any needed prototypes to mitigate risk, because whenever we identify those risks, we need to develop such prototypes to mitigate those risks. So only the identification of risk is not important, but we should know that how we can reduce the chance of having that risk, or in other words, we can mitigate that risk. So if we have that strategy, then obviously that will give us a big advantage. Obtain stakeholder concurrence on scope definition, expenditure, cost, schedule estimates, etc., etc., because the client or the customer need to be part and parcel of this phase, especially the inception phase, because we need to finalize those requirements. We need to finalize the scope. We need to finalize the cost, schedules, and everything. So it means the involvement of the stakeholder is very much important at all levels, from the top management to the middle tier, and also the lowest tier or the operational management as well. So it means we must have that strategy where we must have the input of all these. So where we have planning, project initiation activities as the part of the inception, planning activities, requirement work, analysis, so on and so forth. So all these activities should be done. And also you can see in the last, testing activities. So this is important because initially whenever we go with these models, we have one concept that testing should be done at the end. No, testing is not done at the end, because testing is a continuous process. So whenever you start developing your system, you start initializing your system, or you are developing the scope, even in that phase you can identify where testing, what are what will be the testing activities which need to be followed. For example, you can easily transform those use cases into test cases later on to be implemented, to be find out, or to be tested. So this concept should be clear, that testing is actually will be done in all phases, but you can say the major chunk of testing will be done in the later phases rather than in the first phase. So primary deliverables of the Inception is a vision document, initial version of the environment adaptation, needed model for the artifact plans, activities, phases, project glossaries, prototypes, etc., etc. These are all important deliverables we have in the Inception phase. Elaboration, as we have briefly discussed in the earlier part, develop the understanding of the problem domain and the system architecture, that how that actual problem works. You develop models to see that how that interaction will take place, what architecture should be there, and try to see that that all those risks has to be, which were identified in the inception phase, should be covered in your design, testing, and obviously later on in the implementation phase. The goal of the elaboration phase is to baseline the most significant requirements. Okay, the elaboration objective is already discussed. The refine the initial requirement and the business case, which were developed in the first phase. The ensure architecture requirement and plans, to refine and establish a baseline architecture, evolutionary throwaway or exploratory prototype. You need, if you are interested to use the prototype approach, you need to see that what type of prototype you will opt for. To establish a supporting environment, produce the project management plan, and the baseline architecture for your product. The primary deliverables, what is the outputs you can say, or deliverables of the elaboration phase? Requirement model for the system, the complete domain model, which includes all use cases, classes, complete definition of use cases, classes, and the complete business model, where you need to know about the cost incur for the development and installation, deployment, connectivities and everything, benefits, risks which are associated with it, complete requirement artifacts, analysis artifacts as well, and architecture model. So how you will implement this, what type of architecture you will go for, and the software project management plan which should be there. Construction phase is more towards the development side, the software design you have, and how you can convert that design into programming or development approaches, what type of applications you will use to develop this, and how you will test it. There are various testing approaches as well. Today we do not have a topic of testing, so obviously I'm not covering the testing aspect, because when talk about an object-oriented software engineering, there we have specific approaches for object-oriented testing as well. So there are some generic approaches of testing, but there are some specialized approaches as well. For example, we have the concept of object testing, class testing, so on and so forth, and all that is important whenever we talk about a construction phase. The goal of the construction phase is to clarify the remaining requirements and complete the development of the first operational quality version of the product. So remember, this is very, very important. So we are in the iterations, and during that iteration, what is the primary goal is to clarify the remaining requirement, whatever the requirement which have been left in the earlier phase. Most of the requirement will try to cover in the second phase. That is the elaboration one, 80% of the requirement, but remaining requirement has to be covered during that construction phase as well. So because it is an iterative process, so it means that moving on into the phases, more detail level is added. When we are in the first phase, inception, we are more abstract. When we are moving towards elaboration, we have more details which are available And similarly, when we move toward construction, we try to have all our requirements to be completed. Minimize the development cost, that is one of the objectives we have. Quality, achieve quality product, quality models, achieving useful versions, complete analysis, design, development, and testing of functionalities, to decide if the software, sites, and users are deployment ready. All these things we need to cover when we talk about construction phase. So important activities we have we have already discussed. Primary delivers our working software system, that is sometimes in the form of beta releases, or sometimes it is subsystems which we want to implement, and we see that how user will respond. Associated documentation, which is very important, because while we are in the design phase and construction phase, we need to know that what are the associated documentation. Let's suppose if testing is being done, what was the testing plan, how those test cases were generated, and how those test cases are being represented in the form of the document. For example, if you have a specification document, how you have developed that requirement specification document based on the requirements of business case you have. So similarly, you have acceptance test documentation, project deliverables, user manuals, which is also important whenever we are developing such applications. So we have to cover all those aspects as well. Last phase is called the transition phase. There we deploy the system in its operating environment, deliver releases for feedback and deployment. So what is the focus on the transition phase? To ensure that software is available for its users and meet their needs, because initiating it, designing it, and then developing it, that is fine. That all those activities which being carried out using standards, everything you have enforced the quality aspect as well. But it is important that that has to be used in an actual environment, in a realistic environment. For example, if you have developed an application for a university, that system has to be implemented, and all teachers, staff, and student has to use it. So we have to see that whether that system works in the same manner as we have conceived or not, which is very important. So transition phase, we actually make that transition happen. So transition phase can span several iterations, include testing the product in preparation for release. So even at the time of release, what we do is we make testing, because if major users will going to use, so obviously we have to 200% sure about any errors, faults which are there, and making minor adjustment based on the user feedback. So at the last time, we also have some sorts of feedbacks which can easily be incorporated. So the transition objectives are: the assess development baseline acceptance criteria, achieve user self-supportability, which is very much important, achieve stakeholder concurrence of acceptance, because it is very important, because actually we are developing that application for the users, and we need to know that whether that support is there, whether that acceptance is there or not, whether they are comfortable in using those applications, whether all those requirements have been met. Is there any change which need to be incorporated? If such can be incorporated. So finalize the supporting material, that is one of the activity. Test the deliverable product, validate the beta test, fine tune the product based on the feedback, not the major tuning but the fine tuning. Parallel operation of replaced legacy system. Sometimes we have the legacy system, we need to implement that system or new system to be implemented. So sometimes we go for parallel operation. So one is there already and you have implemented the new one. So how you can go with the implementation of that. Convert operational databases. There is a need of conversion. You have a data available. How you can transform that data into the new system, so on and so forth. Training of users, of course, is very much important all the time. So short-term trainings and long-term trainings are also a part of it. Transition deliverables, the final product onto a production platform. Other deliverables as well, which include the manuals and other things. This is, you can say, a two-dimensional diagram. There you have workflows on the left hand side, on the You can say the y-axis, where you have requirement flow analysis, workflow design, workflow implementation, workflow analysis, test workflow. And on the top you can see you have inception, elaboration, construction and transition. So you can see in this diagram that the activities are spanned not in the given boxes or dotted line, but you can see that in the inception phase the requirement workflow activities start from the inception phase, but it also covers the elaboration phase as well. It is overlapping. Similarly, you can see the analysis workflow and is the major chunk is in the elaboration phase, but there are some activities which starts in the inception phase as well, and it can move on to the construction phase, as you can observe. Similarly, in the design phase you can see the major activities there in the construction phase, but there are certain activities which is there in the elaboration phase as well. And if you see the implementation workflow, the major chunk is in the construction phase, but there is some part which is there in the transition phase and some part in the elaboration phase as well. And if you talk about testing, testing starts from the inception phase, although there is less gravity, and you can see the major chunk of testing is being done in the construction and transition phase. So it means that these phases are not discrete. Actually these phases are overlapping, they are not mutually exclusive. So it means the workflows and the activities which have to be done in various phases are overlapping. So we cannot say that they are totally mutually exclusive. So most of the requirements of work or workflow is done in the inception phase, as you can see. However, some is done in the later phase. Similarly, most of the implementation work you can see is done in the construction. However, some is done either and some later. Basic characteristics of the unified process include that object-oriented, use-case-driven, architecture-centric, and iteration and incrementation approach. So object-oriented, yes, it utilizes object-oriented technologies, methodologies, and principles. So classes are extracted during object-oriented analysis and designed during object-oriented and designed during object-oriented design. So major task is to identify those objects, then classify those objects, and try to develop the relationship among those classes and increase that detail level. It means include all those relevant methods and properties which are associated with those classes to have the formal design, and later that design can be implemented. Use case driven, yes, basic character of one of the basic characteristics of the unified process, that is use case driven, and the use case model is the pivotal model, because the use case model is actually the model where we actually find out all those functional requirements which has to be part of the system, the actors which are part of that system, their association with those use cases, and the detailed representations of those scenarios. And if there is gap, or if there is you can say if your use case model is not complete, then all other phases will be affected. So use cases bind these workflow together. So if use case is not actually the actual representation of how the system works, then obviously you cannot improve the implementation workflow or design workflow. So that is why it is called use case driven. Even on the basis of the use cases, you identify the classes. Even on the basis of use cases, you identify test cases. Even on the basis of use cases, you go for the validation test. So it means that it is use case driven. This is also architecture centric, views of the whole design with the important characteristic made more visible, and obviously the most significant model which we need to express is the class diagram. So it is architecture centric, means we need to know the framework, the architecture, and how various aspects of the system need to be represented. Iteration and implementation, way to divide the work. So you see in the phases as well, there is a division of work. There are certain iterations which need to be performed. For example, for as far as requirement is concerned, these requirements are being taken in the first phase, but it needs to be refined in the next phase as well. and even to the third phase. So it means the iteration are the steps in the process, and increments are growth of the product. The basic software development process is iterative. Each successive version is intended to be closer to its target than its predecessor. It means it needs improvement. So every time we have a new version, we include more details, we add more details, and we improve it. Thank you so much to be with me, and obviously looking forward to have your feedback, and we will come out with more lectures in object oriented software engineering domain. Goodbye.